Today we're looking at how to rationalize a denominator, and this is going to build on our previous lessons about rational numbers and radicals. So what does this even mean? It turns out that when we write down fractions, we try to write them down in what you might call standard form. Okay, so standard form, and when you simplify a fraction, essentially you're trying to simplify it down to standard form. So let's look at a few examples of fractions here. What if I have a fraction 4x over 10? Well, is this sort of simplified? Is this in standard form? And the answer is no. We can simplify this further, right? We could make this into 2x over 5. Because in this first example, 4 and 10 both share a common factor. We try to cancel that out, put it in lowest terms, right? This would be sort of standard form for a fraction like that. What if we had another fraction? It was, say, 7a to the negative 2 over b to the negative 3. Well, once again, we don't see this very often because we don't like negative exponents. Essentially, we try to make it so that all of the exponents are positive, and that would be sort of a standard form. So to do that, we'd have to take the reciprocal of a to the negative 2 and the reciprocal of b to the negative 3. We would wind up sort of flipping things around. We'd get 7b cubed over a squared. This would be standard form. Likewise, we don't like having a radical in a denominator. Okay, this doesn't look super great aesthetically. This is not what we're looking for. We want to try and convert this into, well, into something else. We want to take that square root, that radical sign, out of the denominator. How do we do that? Well, that is what rationalizing the denominator means. Okay, so let's see how we can do that. So if we have this 1 over root 2 fraction and we want to eliminate this radical sign in the denominator, what are we going to do? Well, it turns out we can do that by multiplying this fraction by root 2 over root 2, right? Why does that work? Because if you do that, of course, on the numerator, you're just going to get root 2, but in the denominator, root 2 times root 2, well, that is just 2, okay? And so what we've done is we've managed to eliminate the radical sign that was in the denominator. And that's because root 2 squared, right? This is the square root. These cancel out. You're just left with this 2. We could also think about this in terms of rational exponents, right? So instead of 1 over root 2, I could think of this as 1 over 2 to the 1/2 power. And essentially, to eliminate the radical sign, what I'm really doing is I'm eliminating this exponent as a fraction. I don't want this to be a fraction, right? So to do that, I'm going to do the same thing. I multiply by 2 to the 1/2 power over 2 to the 1/2 power. And when I do that, well, in the top, I just get 2 to the 1/2 power. That's root 2. But in the denominator, now I'm adding these exponents, essentially. I get 1/2 plus 1/2. Well, that's 2 halves. Well, that's just 1. That's just 2, right? So we get the same answer. It's just root 2 over 2 using exponent rules here when you write it as a rational number. So that's the idea. We can sort of multiply this original number by something over something, and that will cancel out the radical sign. Okay, so let's look at a slightly more interesting example here. What if we start out with 1 over the cubed root of 4? Okay, what we want to do now is we want to eliminate this radical sign in the denominator. That is rationalizing the denominator. We get rid of any kind of rational exponent, right? In the denominator, you rationalize it. Okay, so what would we try and do here? Essentially, our goal here is to get this as a 4 cubed, because once we have the cube root of 4 cubed, that'll just be 4, right? So right now we don't have that. We have 4 to the 1st power, so you can imagine essentially we have to multiply by the cubed root of 4 squared, right? And we'll do that on the top and bottom. Because when I do that, on the top, I'm going to get the cube root of 4 squared. That's the cube root of 16. In the denominator, I'm going to get the cubed root of 4 cubed. And that's really what we're looking for, because now that eliminates the radical, as these essentially cancel out. So I'm left with now, in the denominator, I'll just have a 4. All right, so I've gotten rid of the radical. What do I have in the numerator, though? Let's think about this. I can think of this as the cubed root of 8 times 2. And the cubed root of 8, well, that's actually 2. So this is 2 times the cubed root of 2 over 4. And I can simplify that one step further. I'll get the cubed root of 2 over 2. And so this is actually what I get now when I rationalize the denominator of this original number right there, okay? So this is doing it using these radicals, right? I could also convert this into a rational exponent. I should get the same answer, right? So if I do that, essentially here I'm going to get, I'll write this as 1 over 4 to the 1/3 power, right? So that's what the cubed root means. And so by the same logic, I want this to be not a fraction. So I'm going to multiply this by 4 to the 2/3 power, right? That way I'll get a 3 over 3 or just a 1. I eliminate that fraction. So of course I have to do the same thing in the numerator. So I will get here, this is just then the cubed root of 4 squared, which is 16, right? And in the denominator, I get 4 to the power of 3 over 3, which is just 1, right? And so once again, I'm going to get the cubed root of, I can say 8 times 2 over 4, right? I'm exactly where I was before. So this gives me the same answer as I had before. I can think of it as either using radical signs or rational exponents. Either way gives me an opportunity to rationalize the denominator. Let's look at the general rule here. Here we've got the general rule on how to get rid of this radical sign. And you can think of it as doing it either with radicals or with rational exponents. So this is sort of two different ways of thinking about the same problem. This way we're essentially eliminating the fraction, right? We're getting an n over n, just get a to the 1 power. And here we're sort of getting rid of the root outside. We wind up with an nth root of a to the n, so it's just an a. Okay, so let's look at an example here, see how this works. What if I'm taking the 5th root of 1 over a squared? Okay, that's the example I want to look at. Well, that's the same as 1 over the 5th root of a squared, and I'm trying to essentially get this 2 and make it into a 5, because if I can get the 5th root of a to the 5, then these will cancel, and I will have eliminated the radical sign, right? So how do I do that? Well, I'm going to have to multiply this essentially by the 5th root of a cubed. Right, and I have to do that to the top and bottom. So I'll wind up with the 5th root of a cubed on the top. And in the denominator, now this is like the 5th root of a squared times a cubed. So that's just going to be, of course, the 5th root of a to the 5th power. And that's it. I've done it, right? So this simplifies down to the 5th root of a cubed over a. Right, there you go. I've rationalized this expression, and essentially I've used this rule right here, right? So I am multiplying this 5th root of a squared by, in this case, n is 5, so 5 minus 2 is 3, right? This n minus m. So by doing that, I'm able to get the 5th root of a to the 5th power, okay? So that's using radicals. If I was to translate this into a rational exponent, I'll get the same thing, right? So this would essentially be then 1 over a to the 2/5 power, right? And so here I need to then, to eliminate this fraction, I'm going to multiply by a to the 3/5, and I have to do that on the top and bottom. So I'll wind up here, this is the 5th root of a cubed over 2/5 plus 3/5 is 5/5, right? So that's just going to be a to the 5/5, which is a to the 1st power, which is just a. Look at that, we get the same answer. Okay, so this is the process you want to follow to rationalize the denominator. Let's try a few practice problems before we call it quits. Here we've got 3 practice problems. Why don't you pause the video here, try them first, then come back and we'll do them together. Okay, so let's try these out. So for the first one, we can think of this as the square root of 5 over the square root of 2, and we need to rationalize this denominator, get rid of that radical sign. We're going to do that by multiplying the top and bottom by root 2. And once we do that, we're going to have essentially the square root of 10 over 2, and that's it, okay? That's as far as we can simplify that. We're going to leave it just like that. And let's look at the next one here. Okay, so once again, I'm going to treat this as the 7th root of x squared over the 7th root of y to the 4th power. Now, having a radical in the numerator is perfectly fine, but this one in the denominator, I need to get rid of that, okay? So to do that, I essentially need this 4, I need that to be a 7, okay? And to make that 4 into a 7, I need to add 3. So I am going to multiply this by the 7th root of y to the 3rd power. And of course, I need to do that on the top and bottom to maintain equality. Okay, so what do I get with that? Well, in the numerator, I'm going to wind up with the 7th root of x squared y cubed. That's fine. And in the denominator, I'll wind up with the 7th root of y to the 7th power, which is just going to give me y. All right, there we go. That's what I'm left with there after rationalizing the denominator. Let's look at the last one here. So for this one, I'm going to translate this into a rational exponent. Sometimes that just seems a little easier to me. So this will be a 2 over x to the 7/3 power. Now this one's a little bit different than the ones we've looked at so far because the numerator of this rational exponent is bigger than the denominator. But the goal is still the same. I don't want this to be a fraction. I need some other kind of number. So if I can make this instead of 7 over 3, if I can convert that to 9 over 3, well then that'll just simplify to 3, right? So basically I need to get this 7 and make it into a 9. That's my goal. So to do that, I'm going to have to multiply this by x to the 2/3, right? So top and bottom, x to the 2/3. I'm going to get then 2 times, well, I can think of this as the cubed root of x squared over x to the 9 over 3rd power, right? So 9/3 here, and that's the same then as 2 times the cubed root of x squared over x cubed. And that then will be my final answer for this. Can't simplify that any further. All right, so hopefully this helped you understand how we can rationalize the denominator of a fraction and put it into standard form. Essentially, we don't want to have any radicals in the denominator, and we can get rid of that by multiplying by some special radical or converting it into a rational exponent, and then using essentially kind of fraction addition to try and get rid of that fractional or rational exponent there. I will see you next time when we start looking at algebraic expressions.